Imagine sitting on the banks of the mighty Saraswati River, thousands of years ago. There is no light pollution, just the raw, overwhelming scale of the Milky Way stretching across the horizon. But the ancient sages, the rishis, aren't just looking at the stars in wonder. They're listening for the rhythm of the universe. A heartbeat measured not in seconds or hours, but in eons. To most ancient cultures, the sky was a map for navigation or a myth to explain the unknown. To the ancient Indians, the sky was a clock, a divine mathematical timepiece of unimaginable scale. Other civilizations built monuments to touch the sky or charted where the planets would appear next. India built equations to measure eternity itself. They didn't just track the stars, they tracked time all the way to its horizon. This is the story of how India mapped the infinite. Over the last few chapters of this journey, we've watched that clock take shape. The Mesopotamians recorded the sky on clay tablets and mapped it with the first zodiac. The Babylonians turned those records into calculation, predicting the eclipse and the wandering planet years in advance. The Egyptians bound the heavens to the life of an entire civilization. Each had learned to ask where the stars were and when they would move. But one question remained almost untouched. Not when a single eclipse would come, but how time itself was built, how deep did it run, and could its vastness be captured in numbers? That was the question India would take up. The ancients of the Indian subcontinent wanted to synchronize human existence with the turning of the cosmic wheel, to align the microcosm of the soul with the macrocosm of the universe. And to do that, observation alone was never going to be enough. They needed a mathematics vast enough to hold eternity. This was India's great breakthrough. Earlier civilizations had recorded the sky and learned to predict it. India set out to measure the shape of time itself. And it found that time was a circle, turning through spans so vast they could only be written as numbers. To understand ancient Indian astronomy, we must change how we view reality. In the West, time is a straight line, a beginning marching toward an end. In ancient India, time is a circle, endless, repeating. A cosmic dance of creation, preservation, and destruction. They measured time in epochs called Yugas, not years or centuries, but vast eras spanning millions of years. The Satya Yuga, the golden age of truth, the Treta Yuga, where harmony begins to wane, the Dwapara Yuga, an age of duality and conflict, and the Kali Yuga, the age of iron and ignorance. And here's the hidden elegance. The four ages aren't random. They fall in a perfect 4:3:2:1 ratio. The Satya Yuga lasts 1,728,000 years. The Treta, 1,296,000. The Dwapara, 864,000. And the Kali Yuga, 432,000. Add them together and you get one Mahayuga, a great age lasting exactly 4,320,000 human years. But the math doesn't stop. 1,000 great ages make a single Kalpa, just one day in the life of the creator god Brahma. That is 4.32 billion years. When modern science finally measured the age of the earth, some 4.5 billion years, it found that one ancient civilization had already been thinking on the same staggering scale, counting in billions of years, while the rest of the world still counted its history in mere thousands. India. To measure these cosmic cycles, the sages needed a robust system. The Vedanga Jyotisha, compiled by the sage Lagadha over 3,000 years ago, it is one of the oldest astronomical texts in human history. It was known as the Eye of the Vedas, because without it, the sacred texts were considered blind. This was no book of mythology. It was a strict manual of applied mathematics, tracking the combined movements of the sun and moon. It mapped the sky into 27 sectors, the nakshatras or lunar mansions, where the zodiac the Mesopotamians had drawn followed the sun through 12 signs. Indian astronomy followed the moon through these 27 star clusters, each one a precise coordinate on the cosmic clock face. A sacred fire ritual performed at the wrong time was considered powerless, or worse, destructive. Timing wasn't just practical, it was the key to cosmic harmony. Astronomy and religion weren't linked. They were the same science. But the true masterpiece came later, the Surya Siddhanta, the treatise of the sun. Legend says its knowledge was given directly by the sun god to an ancient entity named Maya. Where the Babylonians had predicted the planets, India reached for the geometry underneath them. The Surya Siddhanta recognized that the planets do not glide in perfect circles, and it corrected for their uneven wandering speed across the sky. It gave algorithms for the timing of solar and lunar eclipses. It estimated the diameter of the Earth. And above all, it carried the tool that would set Indian astronomy apart: trigonometry and the sine function known as Ja. Our modern word, sine, traces back through Arabic straight to this Sanskrit term, a piece of ancient India hiding inside every trigonometry textbook today. According to the Surya Siddhanta, the length of a tropical solar year is 365.242176 days. Modern science, using atomic clocks and satellites, puts it at 365.242190 days, an error of mere fractions of a second. And it was reached with nothing but the naked eye, geometry, and a patience measured across generations. This text launched a golden age of Indian mathematics. In the 5th century, a 23-year-old named Aryabhata wrote a slim masterpiece called the Aryabhata. In it, he calculated the value of pi as 3.1416, accurate to 4 decimal places, and, remarkably, he called that value only approximate. A choice of words many scholars read as an early brush with the idea of an irrational number, 1,000 years before Europe would prove it. He proposed that the Earth was not static, that it rotates on its own axis, creating the illusion of the stars wheeling overhead, and he measured the length of that rotation: 23 hours, 56 minutes, and 4.1 seconds. The modern figure: 23 hours, 56 minutes, and 4.09 seconds. He was off by a fraction of a single second. He even calculated the circumference of the Earth to within a couple of 100 kilometers of the true value. And he explained the one thing the earlier astronomers never could: the mechanism itself. An eclipse was not a demon swallowing the sun and moon. It was the precise shadow cast by the Earth and the moon. Babylon had learned to predict when an eclipse might come. By understanding the geometry of those shadows, India could begin to say where on earth it would fall. The torch passed on. Varahamihira gathered the astronomy of 5 competing schools into a single great encyclopedia, preserving knowledge that might otherwise have been lost. Then came Brahmagupta, who formalized the rules for the number 0, a concept that would eventually power every computer and algorithm in the modern world. He treated 0 not as emptiness, but as a number you could add, subtract, and multiply. And in the same breath, he reached for something remarkably close to gravity, writing that the earth draws objects toward itself, just as it is in the nature of water to flow. Then, in the 12th century, Bhaskara II wrote works so advanced they flirted with calculus itself, describing the instantaneous motion of a planet and stating that a number divided by 0 yields the infinite. For 1,000 years, generation after generation, India refined the cosmic code. But the most astonishing chapter is one the world almost forgot. In the 14th century, in a quiet corner of southern India, a mathematician named Mahava of Sangamagrama did something no one on earth had done before. He took the sine, the cosine, and pi itself and expressed them as infinite series, sums that go on forever, each term bringing you closer to the exact answer. This is the foundational machinery of calculus, the same infinite series that Europe would later celebrate under the names of Newton and Leibniz. Except Madhava and his students in the Kerala school wrote them down nearly 300 years earlier. They had grasped the concept of a limit, of infinity, tamed by mathematics. While medieval Europe was still centuries from the idea, his successor, Nilakantha, even devised a model in which the planets circle the sun. Here, on the banks of a river in Kerala, humanity took its first steps into the mathematics of the infinite. But all this math had a human purpose. It governed everyday life through the science of Muhurta, auspicious timing, the belief that the position of the planets creates specific energetic windows on Earth. Time is not neutral. Certain moments are ripe for creation, others meant for stillness. Egypt had bound the heavens to the life of a kingdom. India bound them to the life of a single person. You wouldn't plant crops, begin a journey, march to war, or arrange a marriage at random. Every major life event, from the birth of a child to the crowning of an emperor, was calculated against the backdrop of planetary motion. The astrologer wasn't a fortune teller. He was a chronometrist, a keeper of cosmic time. The universe wasn't happening far away, in the cold void. It was happening right now, in your life, in this exact breath. Centuries later, this obsession with precision took physical form at the observatories of Jantar Mantar, built by Maharaja Jai Singh II. These aren't just monuments, they are massive stone astronomical instruments. The largest stone sundial in the world stands here, measuring time to an accuracy of about 2 seconds. The abstract math of the Surya Siddhanta pulled down from the heavens and carved into stone, something you can walk through. What India achieved was a monumental leap in human thought. They recognized the universe was not chaotic, but governed by strict mathematical laws, separating the whims of the gods from the predictable mechanics of the planet. And they realized something modern physicists still explore. The mathematics needed to understand the distant stars is the same mathematics needed to understand reality itself. To map the sky is to map the mind of the Creator. Their calculations did not stay locked in the subcontinent. The numbers they invented to track the Yugas, including zero and the decimal system, traveled the ancient trade routes. In the House of Wisdom in Baghdad, scholars of the Islamic Golden Age translated the Surya Siddhanta and refined its trigonometry. Eventually, the knowledge flowed into Europe, into the hands of mathematicians like Fibonacci, fueling the Renaissance and the scientific revolution. The very numbers we use to calculate the trajectory of satellites, the algorithms we use to launch rockets into deep space, were born from ancient Indian sages, men who simply wanted to calculate the perfect moment to light a sacred fire. The legacy is woven into daily life. Every time a computer runs on zeros and ones, every time a calculation rests on the decimal digits and the zero at their heart, every time a satellite is guided across the sky by trigonometry, you are leaning on tools that trace back to ancient Indian mathematics. Even today, millions still consult astrological almanacs, the Panchangs, direct descendants of the Vedanga Jyotisha. That almanac still rests on 5 pillars, unchanged for millennia: the Tithi, the lunar day; the Vara, the weekday; the Nakshatra, the star; the Yoga, and the Karana. 5 threads of cosmic time, still woven into millions of lives. Empires rose and fell, languages died out, but the math survived, the clock kept ticking. So what did India add to humanity's understanding of the sky? Mesopotamia had recorded it, Babylon had predicted it, Egypt had built a civilization around it. India did something none of them had. It turned the sky into pure mathematics, and then made that mathematics infinite. It gave the world the zero and the decimal, the sign and the endless series, and the vision of time so vast it reached across billions of years. Before India, the cosmos was something to be watched, feared, or foretold. After India, it was something to be calculated, down to the fraction of a second and out to the edge of eternity. By calculating the breadth of Brahma, they didn't just map the stars. They gave humanity the mathematical language we would one day use to reach them. The universe is ticking, and India taught us how to listen. But India was not the only civilization listening to the cosmos. Far to the east, another had been watching the sky for longer than anyone else on Earth. In our next episode, we travel to ancient China. There, the heavens answered to the emperor himself, and the court astronomers kept the longest unbroken record of the sky in human history. A vigil so faithful, they caught exploding stars and returning comets that much of the world never thought to write down.